All right, guys, we're starting a little bit of identities to finish the school year off, just so you have an idea as you head into whatever next year's math class might look like. I'm going to do the first one with you, and then I'd ask that you pause the video and try the next two. We're going to see what results we get. So what they want us to do is find the value at sine of pi over 2. So remember, sine is your y. And so if we come to our unit circle, this is going to be 1. So really here, this is going to be 1 squared. And then if I come here to cosine of pi over 2, I see that it's 0. So 1 squared plus 0 squared, that just equals 1. Right? You're going to do that for the next two. All right, so hopefully you took the time to do that. This is going to be proving one of our first identities, and so it was kind of useful to go through this. So at pi over 4, you could see that both cosine and sine is root 2 over 2. So this is going to be root 2 over 2 squared plus root 2 over 2 squared. That equals 2 over 4 plus 2 over 4, which equals 4 over 4, which equals 1. We're starting to see a pattern here. So what do you guys think the next one's going to equal? So at 2 pi over 3, I'm over here in quadrant 2. Cosine is negative 1/2, and sine is root 3 over 2. So we're going to have root 3 over 2 squared plus negative 1/2 squared. Well, this is going to equal 3/4 plus 1/4, which equals 4/4 or 1. So we have just proved our first identity. So get ready to take some notes. You'll want these in your notebook or some way that you have them available for your practice problems for this week. Well, this one is not too bad for notes. It's just giving you a definition of an identity. So an identity is something where both sides equal each other. So you can see that we have these examples for identities that if I simplify the left-hand side, it does equal the right-hand side in both of these cases. What is not an identity is, this is an equation. It's not an identity. X squared does not equal 5x minus 6, no matter how much simplification I would do. These are equations. These are identities because if I took x to the 5th divided by x to the 3rd, I would get x squared. All right, here is your massive note-taking slide. The top part are what we call fundamental identities, and they are using what we have on the unit circle or what we know about cosine and sine. That cosine is my x value over my radius, which is your hypotenuse on a circle. Sine is my y value over my radius. And just remember, on the unit circle, your radiuses are 1. But these are your definitions. So these are what we would call the fundamental identities. And then down here, we have the fundamental trig identities, which shows the relationships between reciprocal relationships over here, how you can write tangent in terms of other trig functions, and then our Pythagorean identities, which we just proved this one in the warm-up. These are all really important. So hopefully you're going to pause and take these down. And then this is showing that if I had a triangle, and instead of calling my hypotenuse h, I'm going to call it r because we're talking about circles here, that I could find the value for r is the square root of x squared plus y squared because of the Pythagorean theorem, because x squared plus y squared equals r squared. And then these are just notations that if I have a cosine value that's squared, I write it like this because they don't want you to think that the angle's been squared. So it was written that way in the warm-up, but these are just notation corrections. And then just to note that sine to the -1 of 0 does not equal this. This is 1 over sine. This is telling me I'm taking the inverse trig function. So those are just some clarifications for this part of our trig unit. All right. Hopefully you had some time to take down the notes. All right. We're going to use those first fundamental identities, if I can get this to focus, to prove this function. All right, I'm going to zoom in a little bit. And so if we go back and we look at our notes for that, I can say that cosine is x over r. So in your assignment for this task, if it tells you to use the fundamental identities, it wants you to use your values x, y, r, all those combinations, or to use these identities up here. So I'm going to have x over r, all of that is squared, plus sine is y over r, and all of that is squared. And we want to prove that it equals 1. And so with identities, you're going to keep manipulating one side of your equal sign until you can see if it equals 1. So what we want to get for our final identity is 1 equals 1. So I'm going to get x squared over r squared plus y squared over r squared equals 1. Now I see I have a common denominator, so I can write this as x squared plus y squared all over r squared. Now remember from notes the page before, we said if we had a triangle, a right triangle, and our hypotenuse was referred to as r, and these are x and y, that x squared plus y squared equals r squared. That's just the Pythagorean theorem. So we can substitute for x squared plus y squared, r squared. We're going to substitute that in there because those are equivalent. So I get r squared all over r squared equals 1. And yes, r squared divided by r squared is 1. So our final part of our proof is 1 equals 1. If you need to pause and get these notes down or think it through, go ahead and do that. All right. We're going to try another one. So this is one of our other Pythagorean identities. So coming back to here, we see that 1 plus tangent squared equals secant squared. We're still using these identities up above. So I'm going to just go in and I'm going to place everything in terms of x, y, and r. So 1 stays the same. Tangent, that is y over x, so this will be y over x squared. And secant squared, or secant, is r over x. So this is going to be r over x squared. Then I'm going to want to carry out the squares on everything. Oops, I don't need to write that parentheses. So I get 1 plus y squared over x squared equals r squared over x squared. And there's a lot of different ways you could look at this, but I'm going to find my common denominator over here. So what do I need to make 1 have a denominator of x squared? Well, I'm going to multiply top and bottom by x squared. So then I get x squared over x squared plus y squared over x squared equals r squared over x squared. Now I see I have a common denominator, so I can combine these terms over one denominator. And then, like on the previous identity, we know that r squared equals x squared plus y squared. So I'm going to replace all of this with r squared. And we can see that those two equal each other, and we have just proven the identity. You might need to pause and take a look at that. And I'm going to let you guys try one. So be ready, have your notes out, be ready to try it, and then see what you get for that. So I'm just going to have you do this top one here. And then I'll show number 4 is just a separate one. So just take a moment, pause the video, and do the top one. All right, hopefully you had a chance to do that. So cotangent is the reverse, or it's the reciprocal of tangent. So this I know is going to be x over y squared plus 1. And cosecant is the reverse of sine. So this is going to be r squared, r over y squared. And then you get x squared plus y squared plus 1 equals r squared plus y squared over y squared. Now we're going to find the common denominator here by multiplying top and bottom by y squared. So we get x squared all over y squared plus y squared all over y squared equals r squared all over y squared. Now we can write it as x squared plus y squared over y squared equals r squared over y squared. We know this equals r squared. So our final step is r squared over y squared equals r squared over y squared. Some of you might be asking, why do I do this? If we got to continue going on to trig, we would need to solve some trig functions for the angle, and we would need to simplify them, and you use identities to simplify them. All right, let's try one more. So tangent of theta, these are actually pretty easy. We know that this is y over x, and we know that sine is y over r divided by x over r. So to prove this one, remember when you divide fractions, you flip the bottom one and multiply. So we get y over x equals y over x. All right, that's it. So if you have any questions on that, please just let me know this week. I didn't assign anything really difficult. So if you have good notes, that should help a lot.